Hello everyone, welcome to this video. In this video, we will see how you can build a DC circuit, a simple DC circuit. So here is once you open MATLAB, so you will see this screen. This is the home page of the MATLAB. And you see that we have different windows. So this is the editor window, this is the command window, this is the workspace, this is the current folder window, and this is the details window. So you are at the tab home, at the home tab. So you need to find here Simulink. So you see here Simulink. So, and once you click on Simulink, we will have a window that shows us different options to select. So what we need to do is to select a blank model. So here we are selecting blank model, and then we will have the model where we can build our circuit, our simple DC circuit. So the model is being created, and here is the model. So let me maximize the page. So here is the space of the model. So first of all, I need to save this model. So I click save here, and it will ask you about a name. So I will say DC underscore circuit. So in MATLAB, you cannot have spaces in the name of the file. So I'm using underscore between DC and circuit. So I'm saving this model. It says you didn't have permission to save this location. Okay, let me change the location. Let me make it on the desktop, and I will save on the desktop. Now the model is saved, and we can start our DC circuit. So we need to build a DC circuit of one voltage source, one battery, and two resistances connected in a series. So I want to have the battery first. What we need to do is to go to the library browser. So I'm clicking on the library browser. I'm going down until Simscape here, as you see Simscape, and I'm clicking on Simscape. In Simscape, you have Simscape electrical. So here we have electrical. Double click on electrical, then you go down to the specialized power systems. Double click on the specialized power systems, then you go down to sources, and then double click on sources. And I see that here I have different types of sources that we can use. So what we have AC current source, AC voltage source, controlled current source, controlled voltage source, DC voltage source. This is the one that we need. And we have here three-phase source, three-phase programmable voltage source, and so on. So we have even a fuel cell. We have different sources here, PV array, and so on. So what we need to have is the DC voltage source. So I'm dragging it using the mouse and bringing it to the model, leaving the mouse, and then I will have my DC voltage source inside the model. And so now I can do double click in order to see what are the parameters inside the DC block. So I see that the amplitude is 100 volt. So in this circuit, I want the voltage source to be 20 volt. So I'm changing the 100 to 20, clicking apply, and then I click OK. Now I want to have two resistances in order to connect them to this voltage source in a series. So again, we need to do the same thing. We need to go to the library. We need to go to the Simscape, to electrical, and then we need to go to passives here. Okay. If you click here in passives, you will see that we have different elements. So what I want to use here, I want to use the series RLC branch. Series RLC branch. So I click on series RLC branch, drag it here in the model, leave the mouse, and then my series RLC branch will be here. So as you see, I can now double click on the series RLC branch. I will choose the type to be only R. So I want to have it as a resistance, and its value, let's say 3 ohms, and its value 3 ohms. Apply and okay. We see that the RLC now is only a resistance, and you can double click. You have here series RLC branch under here, and you can double click on this and change it. I will say, for example, R1 equal to 3 ohms. So this is my first resistance. So now it is R1 and it is 3 ohms. Now I want another resistance. So I can go the same way to bring another RLC branch, or I can just do right click and then copy, and I click anywhere in the model, right click and then paste. Then I will have this resistance copied here. So what I need to do, I want to change its value if necessary. And in this case, in this example, I want to have it 2 ohms. So I'm doing apply, okay. And also I'm changing the number here to be 2 ohms, so I will not be confused with the results. So now it is 2 ohms. I will delete this number 1 at the end, and here it is. Of course, you can rotate it, you can flip it, whatever. And as it will be a single loop circuit, so I need to have one current measurement or one ammeter to measure the current in this circuit. So again, I want to go to the library, and I want to go to the Simulink electrical specialized power systems, and then you need to go to sensors and measurements. So if I click on sensors and measurements, I see that I have a current measurement device. I drag it here into the model and leave it. Now it is here in my model. Now I can connect it in a series with the circuit. So now I can connect the components by dragging lines using the mouse. So I'm using the mouse and dragging this line and completing the circuit in this manner. As you see, I completed the circuit in this manner, so you can arrange it as you wish. And as you see, I need to show the value of the current measurement. So in order to show the value, I need to have a display block. Again, either you go through the library, or you can double click anywhere in the screen. So if you know the name of the block, I'm typing display, and you see before even finishing the word, I have the display here. So I can select the display, and here is the display, and the display will show me the value of this current. So what I need to do is to connect the output of the measuring device, current measuring device, to the display, and this display will show me the value of the current that is flowing through this single loop circuit. In order to do this model to work, we need to have an environmental block, and this environmental block is called Power GUI. Again, you can go through the library, or you can double click anywhere if you know the name of the block. So you type power. I wanted to type power, and it's already here, so I'm selecting it. So this Power GUI block is a standalone block. So I'm selecting it. It is continuous mode, and I will leave it in the model. I don't connect anything. Actually, there is no inputs, no outputs to connect anything to that. So now what I want to do, now I know the current that is flowing through these two resistances and through the source, but I want to measure the voltage across all these elements, across the source itself, across the resistor R1, and across the resistor R2. So let me type here, correct this to R2. So what I need to print is a voltage measurement device. Again, you can go through the library or you can double click anywhere and start typing measurement. So you will have voltage measurement. So I want this voltage measurement. So I will bring this voltage measurement here to measure the voltage across the source. And as you see that I need to connect the plus with the positive side, the minus with the negative side. So it is better to flip this block. So I will click right click and I will do rotate and flip and I will flip the block. So I will flip it right to left. Now I see that the block is flipped, so I can continue the positive side to the positive side and the negative side to the negative side as. And in order to see the voltage at the output, again, I need to have a display. So you can copy this display. So I can right click, copy, and now anywhere in the model, right click and paste the display. And again, I need to flip this display. So I will do right click, rotate and flip. So flip block and the block will be flipped and then it will be much easier to connect this display. So this display will show the voltage across the source. So let me type here. It will show V source, VS, and this display will show the current in the circuit. So, and we have only one current. So I will type only I. So this will show the current, okay? So this is how to connect the voltage source. Of course, the voltage source is connected in parallel with each component. Now I want to have another two voltage sources to measure the voltage across R1 and R2. So again, I can take this component, right click, copy, and then somewhere I will do paste. I will bring this component here. And as you see, I need to rotate it in order to make it in a better way. So I want to rotate it, let's say, let me rotate it first. So I will rotate it counterclockwise. Again, I need to rotate it again counterclockwise. And as you see, I can rotate it once again counterclockwise. And as you see now, I can connect, but the positive side is here, the negative side is here, so I can flip it. Of course, you can connect it without doing the flip, and so I will flip it left to right. So now I have the positive side of the voltage measurement at the positive side of the resistance. So this red positive side, and the negative side is on the other side. And I need a display. So I will copy this display, copy, and anywhere in the system, I will paste and I will connect it. Now this will be equal to V across R1, V across R1. Again, I want to do the same thing for the second resistor. So I can select the voltage measurement device. I will click shift. So I will select this line and I will select the display. And now right click, I will copy all three of them. And now anywhere in the system, I will do paste. You can use the arrows or the mouse to move them. And then I can connect the voltage measurement device across the second resistance. Okay, now I have everything seems to be fine at this point. So this is the stop time. So this is the time for which you are doing the simulation. So this is 10 seconds. 10 seconds is too much for this circuit. I will have only 1 second. Of course, you can keep it whatever you want. So let's run the circuit by clicking this run button and see whether everything is fine or whether we have any errors. So I will run the circuit, and we see that the circuit is compiling now, and it seems fine. There is no errors. And here we see the voltage across the source is 20 volts, and actually this is the voltage that we had here. So if I double click on the source, I see that I have 20 volts. So we are measuring the correct voltage. And we see that we have two resistances in series, one 3 ohm, the other one is 2 ohms. So the sum of them is 5 ohms. And if you divide the 20 by 5 ohms, you will have a current of 4 amperes. So this is the current 4 amperes in this circuit. This current, if you multiply it by 3 ohms, 4 times 3, it will be 12 volts, the voltage across this resistor. If you multiply this current 4 amperes times the resistance here, 2 ohms, it will be 8 volts. Of course, yeah, we can also add the unit of measurement. So here I have I do comma and write ampere, so it is measured in ampere. This voltage source is also Vs, comma, measured in volts. And the same thing for the other voltage measurements. So it will be comma and volt. And for the voltage across the other resistance, also I will do comma and volt. So now I have even the measuring units indicated. So now the circuit is complete. Now I want to measure the power. And since we have only resistive circuit, or because it is a DC circuit, so we have only active power. And of course, we will not have any reactive power in this circuit. So let me bring the power measurement device. So again, you can double click anywhere here. So I will select power measurement device, or I will write measurement. So I'm typing measurement, and I see that here I have the power measurement device. So I click and I see that this is power measurement. Make sure that it is continuous power measurement device. And what see in this device? We see that it has 2 inputs and 2 outputs. So what are these inputs and outputs? So one input is V, the voltage. The other input is I, the current. And we have 2 outputs. One output is P, the real or average power. The other output is Q, the reactive power. So these outputs should be connected to displays in order to read the numbers. And these inputs should be connected to that component for which you are measuring the power. So for example, let's measure the power for the source. So I'm connecting the voltage here with the voltage of the source. So I'm taking the voltage of the source, and I'm connecting the current to the current, and the current here is only 1 in the circuit. So the current is only 1, so we can connect the current in this way. Okay, so I'm connecting the current by this wire or signal, and I'm connecting the voltage here. So now I want to connect one display, so I will copy this, I will paste it, and then I will connect this display to P. And now I can change the name of this display to P power of the source, comma, in watts. So this is the power. You don't need to connect the Q because the Q is 0. If you want to make sure that it is 0, you can connect a display. So let me run the circuit now. Before running the circuit, you need to double click on this power component, and you need to make sure that the harmonic numbers is only 0. 0 corresponds to DC circuits, 1 corresponds to fundamental AC circuits. So you need to make sure that this is 0. Here we have the phase frequency. You don't pay attention to the phase frequency here because we have DC circuit. So I will do apply and then OK. And if we run the circuit, we see that the power delivered by this source is 80 watts. 80 watts. This means that this resistance will absorb some power, and this resistance will absorb some power, and the sum of the power absorbed by these two resistances should be 80 watts, in order to have power balance. So now let's measure the power for each of these two resistances. So in order to do so, let me see, copy this power measurement device. I will click on Shift now. I will click, I will choose this line and this display. And now right click and you select copy. And anywhere in the model, you select paste. So here we have it. So I want to connect it somewhere for the resistances. So let me have this one here. So let me see if I can go up. So I can go up here. So the first one, and now the second one. So I will select, I will do again paste. So this will be the power for the second resistor. The power for the second resistor. So I will try to make them okay. So as you see, the name of this power measurement now is power measurement 1, power measurement 2, and this is power measurement. So you can click all the time, you can click this square, so you can use, optimize the use of the screen, okay? So now as you see, I'm selecting all these once again in order to make it just symmetrical with each other. Okay, so you can rename this power measurement device, and you can have it, for example, for the source, PS or source. You can write source. And here for these two, we can write here, for example, R1. So this will be the power measurement for R1. And here we can type R2. So it will be the power for R2. Okay. Now, and also here. So I will say here PR1, and it will be in watts. So I will delete this one. And here we will have PR2, and I will delete this too. So 1 and 2 are the index that MATLAB is automatically or by default gives. Okay, now I want to measure the power in resistor 1. So now I want to connect this voltage to voltage of resistor 1, and here is this voltage. And now I want to connect the current, this current input to the current through resistor 1. And the current through resistor 1 is the same as the current in this circuit, because we have single loop circuit and then we have only one current. So I'm taking this current. Again, for this resistor 2, I will connect the voltage here, the voltage from 2. And the current is the same as this current. So, and so you can connect this current to this line, because this line is coming from the same current, okay? And we assume that to have now the power consumed in R1, here we have the power consumed in R2, and their sum should be equal to 80 in order to make sure that we have power balance. Okay, so I will run the circuit, and I see that I have 48 watts here, and here is 32, and 48 plus 32 is equal to 80. So this source delivers 80 watts. This resistor consumes 48 watts, and this resistor consumes 32 watts. Don't forget to save your circuit from time to time, so you will not lose your hard work. So as you see, this is a simple DC circuit with two resistances connected in series. We used the current measurement device. we use the voltage measurement device, and we use the power measurement device. So you need to make sure that if you are doing DC circuit, you need to make sure that you have only 0 here in the harmonic numbers, okay, for the wattmeter. So this is the DC circuit. Of course, you can change any values of the source of the resistors, and then these readings will change automatically. Okay.